All right, hey Erica, or whoever's watching this video, this is day 2 of Trig Review. We are going to try to get 15 questions done today, but we have to finish up question 15 yesterday because we got caught on the bell. So, finishing up solving number 15. We got the 8, which is the negative b part. We've got to have the square root of that stuff, okay? 4 times 4 times 1. What does that become? 16. Is it positive 16, negative 16? Negative, right? So 64 minus 16 is like 48. 48 all over 8. Okay. I'm going to go ahead and break 48 down. Yeah, I'm going to break 48 down. What goes into 48? 4 and 12, but we want to use 16 and 3 instead because that's the biggest option, okay? So the square root of 16 is 4. The square root of 3 just stays the square root of 3. So I'm going to put him over here. This is 4 square root of 3. Now I can do one more thing, which is divide all 3 spots by 4, okay? So 2 plus minus just the square root of 3 because the 4 is gone, all over 2. There you go.
But then can't you get rid of the 2?
No, because it has to reduce all 3 spots.
Ah.
All 3 spots.
That's stupid.
Yep, all 3 spots. Good question though. Okay, what does this thing do for me, by the way? What is that thing? Those are the zeros, right? And there's still 2 numbers there, technically. They're just ugly decimal numbers if I would solve them out, right? All right, next. Find the number of real solutions by computing the discriminant. Okay, let's talk about what the discriminant is. What's the discriminant?
It's the b squared.
Just the stuff underneath. So b squared minus 4ac. It's the stuff underneath of the square root. Okay, now, given that that's underneath of the square root, if that number comes out to be negative, what does that tell me? What? It's imaginary, which means there are how many solutions? No solutions, or no places where he crosses, right? If that number is a positive number, how many solutions will I have? Like it's like here, like let's say the square root of a negative something. This is the square root of a positive something. There's 2 solutions. Why 2?
It's plus minus.
Because it's plus minus, right? Okay. And if that number is 0, there is only 1 solution. How's come?
It's plus minus.
Because you're adding 0 or subtracting 0, which is the same thing. Okay, so 1 solution for that. All right, so that's the rules. Okay, we got to do b squared minus 4ac for this thing, but not yet.
You have to add the 7.
Yep, minus the 70t over. So we've got 25t squared minus 70t plus 49 equals 0. And then we got to do our ABC stuff. All right, if you need to write it out, A is 25, B is negative 70, and C is 49. These are huge numbers. Okay, all right. Can I zoom in on things? Are you done writing? Possibly, yes, sure. All right, so B squared is negative 70 squared. Make sure if you're typing this into your calculator, you put it in parentheses, or I would just leave the negative off because you know it's going to turn it positive, right?
Mm-hmm.
Right, when you do the b squared part, okay? All right, so 70 squared is going to be like 4,900. I don't have to have a calculator. 4 times 25 is 100 times 49 is 4,900. So the discriminant is 0. That's what I'm looking for, which means I have 1 solution or 1 real root where he crosses. Okay? What does it look like when a parabola only has 1 solution or 1 place that he crosses? Yeah, the vertex, so he's got, you don't have to draw this, but it's something that probably looks like this where he's just touching at 1 place, right? That's what that looks like, okay? He's not crossing and then going back up. He's just touching, okay? Good? All right, let's draw a picture. A triangle has an area of 96 square inches, and its height is 2/3 of its base. All right, here's my triangle. And the area is 96 square inches squared, okay? The height is 2/3 of its base. Okay, so this is going to be my base. I'm going to call it B. And the height is this guy right here. I'm going to call it H, okay? The height is 2/3 of the base. So the height is means equals. H equals 2/3 of the base. How do you want to write that?
2/3 x.
2/3. I'm going to call it, I'm just going to say 2/3 B, whatever, right? So I have a base, and then I have a height measurement that's 2/3 of the base, okay? Now, how do you find the area of a triangle? Half times the base times the height, okay? All right, now I'm gonna plug stuff in. What do we know the area is?
96.
96. What do I know the base is?
1/2, 2/3.
No, we just called the base B,
B
right?
squared.
And the height is
Wait,
2/3 B. You see what I'm doing here? I'm plugging numbers in for B and H and stuff, right? We just left B as B. If you want to switch it to X, I don't care. But we just left B as B, and then we left H as 2/3 B. Questions about this? Is this confusing? Okay. All right, so I've got 96 equals. I'm going to combine all this stuff together. You can take a half times 2/3. What does that make? 1/3, right? Okay, 1/3, and B times B is B squared. Okay, then what? If I need to zoom out, you holler at me, okay? How do I solve for B? Divide by a third or multiply by 3. So 96 times 3 is 270 plus 18, so 288. Okay, is B squared, and then take the square root. Now we put the square root in technically, which means it should be plus and minus, but we're talking about a length. So it's only going to be positive. What's the square root of 288?
16.97.
16.97. Okay. All right, that's the base. The height is 2/3 of that. 2/3 of the base, right? Okay, so take that 16.
11.31.
Is 11.31. Perfect. So base and height. Now, if you take half times the base times the height, I would check that, right? Take 11.31 times 16.97 and take half of that. And you should get 96. I would plug that back in and check. Now, you might not get 96 exactly because we rounded, but you would get 95.9 or something like that, right? Whatever. Okay, questions about that? Draw a picture. What are the base and the height of the triangle? Got it. Okay, 18. How do I do this? You just do. This is an absolute value that I'm solving. How do I do that?
You have to do 2 different ways.
I have to do 2 cases. Case 1, case 2. That's always absolute value. You have to solve 2 cases. Okay? Case 1, we just drop the absolute value bars. Case 2, what does case 2 look like?
It's just the things in the middle are.
Yeah, the 2x minus 1, you put a negative on the outside of it. Because the fact that it's an absolute value bars, I don't know if it was originally positive or originally negative. So I have to look at both cases. And then we just solve from there. So here, case 1.
Oh, wait, we have to do the line thing.
What?
The number line?
No, because that's inequalities. Eventually we will, probably. All right, I'm going to add the 3 over also. So I have 2 equals 2x. Did you get x equals 1?
Yeah.
There we go. Okay, that's the left case. Right case, I don't know. What do you want to do with the negative? Distribute it through? Yeah. Okay. Negative 2x plus 1 equals 4x minus 3. Okay. I'm going to add the 2x over. And I'm going to add the 3. 4 equals 6x. And divide by 6, which is 2/3. Was that too fast? I'll leave it up there for a second. Okay. Doing all right? All right, 19. We're just still solving for x. How you want to do that?
Take 2 to the third.
So the first thing you want to make sure and do is make sure that the radical is isolated. So like this is by itself, right? If they would have had like plus 4 equals 2, I would have to subtract the 4 over first, correct? Okay, so make sure it is by itself, so we can just go ahead and take it to the third power. X squared minus 1 equals 8, and then what?
Add the 1 over.
Add the 1 over. So x squared equals 9. And then take the square root. X equals Plus minus 3, don't forget it. We put the square root in there, so it has to be positive, negative. That's it. Good, good? All right. Negative infinity to 4, this is called what notation? You remember? What?
Is it interval?
Interval notation. It's interval notation. They just want us to put that on a number line. Okay, so negative infinity to 4. How do we do that?
Closed circle.
I'm gonna put 4 in the middle. He says there's a closed circle on 4 and it's going to the left. Okay? This is unbounded on the left side because it goes to a negative infinity. Sometimes you'll have two numbers, in which case I'll put two numbers that are just looped between. But this one's not, just goes on forever to the left. Got it? Questions about that? Do I need to write anything down, like a bracket is a closed circle, a parentheses an open circle? If you need to, write it down. All right, 21. We have two inequalities. We have like this chunk right here and this chunk right here. What?
You gotta separate it out.
Yeah, let's separate it. So let's do this chunk over here. So 2x plus 3 less than or equal to 5x plus 6. Let's solve that over there. And then I'm going to do this chunk. 5x plus 6 is less than negative 3x plus 7. We just solved two different pieces. And we get two answers, kind of. Okay? All right, on the left, I'm going to subtract 2x. And I'm going to subtract 6. So negative 3 is less than or equal to 3x. Because I don't want to divide by negative. It doesn't matter. You can if you want to. That's fine. X is that of negative 1. Or if I flip it around, x is that of negative 1. Okay. All right, next. I'm going to add 3x. And I'm going to subtract 6. So 2x is less than 1. Make sure you're checking to see if I'm doing this right. I don't know.
Shouldn't it be 8x?
Correct. See? 8x is less than 1. Divide by 8. There we go. X is less than 1/8. I actually didn't mean to do that. So if you want to, negative 1 is here and 1/8 is here. 1/8. I keep putting 1/2. 1/8 is here. Right? 1/8 is on the right side. X is less than 1/8, so it's an open circle, and x is greater than or equal to negative 1. So it goes like this. That's what my answer would, like my solution would look like on a number line. What is that in interval notation?
Bracket
negative 1.
1/8. Oh, or print.
Yep.
Yeah.
That's what that would look like. Okay, so that's switching into interval notation, which is what we're doing in the next one. Interval notation. You could have left your answer as these two individual pieces because I did not tell you and specify to do interval notation, but just so you're prepared for that. Okay, good? All right, next one. Solve that thing and write the solution in interval notation. How do I solve that thing? Two cases, right? Okay, so I've got 2 minus 3x is greater than 4. And I've got negative parentheses 2 minus 3x is greater than 4. Okay? Those are your two cases. Let's solve the left one first. So I'm going to subtract 2. And negative 3x is greater than 2. And divide by negative 3. And flip the sign. X is less than negative 2/3. How about that? All right, what would you like to do for the second case?
Distribute.
You want to distribute the negative? Okay, sure. So negative 2 plus 3x. That actually makes it nice because then my x turns positive. And add the 2. So 3x is greater than 6. And divide by 3. X is greater than 2. Okay. Before I do interval notation, I'm going to put this on a number line because it helps me a little bit. Negative 2/3 is going to go here, and positive 2 is going to go here. So put your numbers in order first. Okay. X is greater than 2, so open circle to the right. Less than negative 2/3, open circle to the left. Okay, this is puzzling. How do I do interval notation?
Infinity, comma, negative.
You're gonna have two chunks, right? Two pieces. Can I zoom in? Are we doing okay? Okay, so I'm gonna have a union here, right? And I'm gonna have like this chunk over here and this chunk over here. Okay. All right. So this one is going from negative infinity, and infinities always have parens, right? Okay. To negative 2/3. Is that a bracket or paren? Paren. Okay. And then 2 to infinity, and parens for both of those. Okay, so that's your interval notation. That's what he looks like. Good? Alright, I'm about to the end of my cord here. Alright. Good? Happy with that? We're ready to move on? I don't want to lose any of you. So holler at me. Alright, 23. This is chapter 3. What did we do in chapter 3? Quadratic functions. Vertex, y-intercept, that stuff. Okay. Alright, given this function, find f of negative 2. What does that mean? Plug in negative 2. Like, give us a bunch of these, right? Minus, but be careful because, like, you can screw them up pretty easy, right? Alright, negative 2 plus 3 is 1. The square root of 1 is 1. Double negative makes positive 2 plus 1. So I got 4. Is that right? Yeah? Sure. Alright. We'll plug in another one. Find f of 0. Okay, this is a piecewise function. Are you going to plug it into the top equation or the bottom equation?
The top one.
Why?
Because it's equal to or less than.
If I'm looking at 0, it's equal to 0 here versus there's not an equal to line there. Do you guys understand how that works? Okay, so we're only going to plug into the top equation to find that. Now if we were doing limits, we would plug into both, you calc kids, okay? But anyway, we're not. So we're plugging in 0 there, and 0 plus 5 is 5. Good? That's f of 0. These are going a lot faster. Lots faster. Look at this. I'm gonna get a lot done. Okay, now they're giving us a graph.
Just wait till 26.
Just wait till 26.
27. That's when you're gonna have to stop and explain it.
No.
It's not hard. You just.
Alright, so 25 says f of negative 3. That means the x coordinate is negative 3. So find a negative 3x. Right here. What y coordinate is it touching?
Negative 3.
Negative 3. What if I said what's f of negative 4? Which one is it?
4.
Is it this one or is it this one?
Negative
It's the bottom
4.
one. Because it's a closed circle. Alright, but for this one it's negative 3. Any questions about that? Like reading that graph, you're just finding the y coordinate. When it says f of something, you're just finding the y coordinate. So the last two problems we just plugged it into the formula. Here we're finding it on the graph. Okay? Good? Okay, determine the vertex. Okay, when they ask you like bunches of questions all in one, I write my stuff down. So determine the vertex.
Plug in 0 for
Vertex, and state whether it opens up or down. So I'm going to write both of those things down so that I don't forget to do one. Because then that means like points get deducted and that's not good. Okay? Alright, so I know what I'm looking for. The vertex. This is in vertex form. Luckily, it's in vertex form. Okay? Do you remember how you find the vertex from that?
Negative 4, 6.
Yep, this guy is an opposite symbol, and then positive 6 is your y coordinate. So negative 4 comma 6. Do I need to write some notes down for that? Like vertex form is typically, this is how you write vertex form. So g of x, a, and then x minus h squared plus k. That's what vertex form looks like. So you can see that the h is negative. That's why we switch it to be the opposite sign, right? Okay, is it gonna open up or down? Up. How do you know that? The 9 is positive. Positive equals up. There you go. That's how I know. Good? Very nice. All right. Okay, this one's the long one. Vertex and y-intercept, because this is in standard form. They call it polynomial form. I call it standard form. Standard form. Okay, when you're finding the vertex of something in standard form. Vertex. Do you remember how you do that?
Is it the, like, the negative b over
Yep.
2a?
Negative b over 2a. And then you plug in. Okay? And then we also want to find the y-intercept. So I'm going to put y-intercept here so I don't forget to do it. Okay? Vertex, y-intercept. All right, vertex. Negative b. I'm going to put it over here. Negative b over 2a equals. Negative b will be negative 4. 2a is going to be positive 4. So this would be 4 over 4, which is 1. So my vertex is 1 comma something. And now I just have to find the something. Okay. 2 times 1 squared is 2. Minus 4 plus 2. Jayden says 0. Yeah? 1 comma 0. That's my vertex. Alright, what's the y-intercept? 2. From here, right? It's just this number. Okay, so in standard form, it's really nice to find the y-intercept. Okay, good? Good, good? Alright. Moving on to the backside. Alright. Okay. Are you ready to write a lot? Okay. Let's do this. Parent. Here's your rules. Y equals, should we do x squared? Let's do x squared so you can see it. Let's say your parent function is y equals x squared. Okay? And I'm going to go, let's go up 3, down 4, right 6, left 5. I don't know.
You should just let us use our little sheet.
I don't know if you have your little sheet though.
I do have my little sheet.
I'm just gonna write it all on this back page right here. I'm just gonna write that whole sheet on here.
This should get you by though. I mean, you only have a couple questions about this, so it's not terribly detrimental. What is up 3 gonna look like?
My little x plus 3.
X plus, I'm gonna do x squared plus 3. What's down 4 look like?
X squared minus
X squared minus 4. Okay, what about right 6?
x minus 4 squared. Squared. Or,
X minus 6 parentheses squared. Yep,
you know.
yep, yep, I know what you meant. Left 5 is x plus 5 squared, right? The thing that I'm gonna put off to the side over here is that use opposite sign, right? Kind of like when you're doing vertex form, the stuff in parentheses, use the opposite sign to tell which way it goes, right? Okay, that's that. All right, let's do a vertical stretch by 2, vertical compression by 1/3, horizontal stretch by 4, horizontal compression by 1/5. I'm trying to use all different numbers so that you can see how this works and then you're not confused. Okay. All right. Okay, what's a vertical stretch by 2 gonna look like? 2 in front, 2x squared. Vertical compression by 1/3? 1/3 x squared. Horizontal compression by 4. And it's in parentheses, 1/4x parentheses squared, which is technically 1/16 x squared if you move it outside of parentheses. Does that make sense? Because you're squaring the factor, right? So this is the same thing as a vertical compression by 1/16, in case you were wondering, right? A horizontal stretch by 4 is the same thing as a vertical compression by 1/16, as long as it's a quadratic function. Confused? If that confused you, don't write that purple part down. Okay, what about a horizontal compression by 1/5? 5x parentheses squared, which is actually 25x squared. So a horizontal compression by 1/5 is the same as a vertical stretch by how much? 25. You see how that works? If that was confusing, don't write the purple part down. All right, use the reciprocal when you're doing a horizontal compression or a horizontal stretch. You flip it. Okay? Any of those rules we need to go over again? Okay, last two, over x over y. Okay, over x is negative x squared. Over y is negative x parentheses squared, which technically is just x squared, right? Because if you take a parabola, x squared, and you flip it over the y-axis, doesn't it make the same thing again? Right? Yeah? Shake your head yes, even though you don't know what I'm talking about. Okay, there you go. There's the rules. Alright, that was a lot of stuff for like 2 problems. But there they are. There's all the rules. Alright, good? Okay, 28, write the rule for g of x. So g of x equals something. Our parent function is x squared, or excuse me, is absolute value of x. And we're doing a couple things to it. So we're horizontally compressed by a factor of 2. So I'm going to do hc by 2. I'm just paraphrasing. hc by 2. Reflecting across the x-axis. So we want to go over x and then shift 3 units up. Okay? Those are the 3 things that I want to do to it. Alright? So, g of x equals the absolute value of x. Okay, what's a horizontal compression by 2 going to look like? Wait a second, wait a second, wait a second, wait a second. You can't have a horizontal compression by a factor of 2. That's a typo, right? Because if it's a horizontal compression, it has to be smaller than 1. So let's go up in here and let's change this because it should be 1/2. Horizontal compression by a factor of 1/2. We'll fix that. That's a typo because you can't have a compression by 2. So horizontal compression by a factor of 1/2, but that means that we're going to use 2 in the equation, right? Because we have to use the reciprocal, right? Okay, so my absolute value, what does he look like now?
The absolute value of 2x squared. Negative 2x.
Well, just wait. The two horizontal compression by 2 just does that 2 there, okay? What does the over x do? Makes a negative out front. What's the up 3?
Plus 3.
Plus 3. Is that everything? Yep. We got it all? That's what your new function looks like. Okay. I think going this direction is harder than like if they would give you this and you have to tell what's done to it. Does that make sense? I think building the equation is maybe harder than tearing it apart. I don't know. Maybe not. Okay, whatever. Okay. So this one, I think this part is the easy part, like dissecting, okay? So x squared is what we're starting with. This is what we're doing, and it says how are they related? That just tells me like, it just wants me to say what are they doing to it, okay? How many things are being done to it? 2 things. So 1, 2. Okay, which one is being done first?
Right, 2.
The minus 2, right? Okay, if I plug a number in for x, you would subtract 2 first before multiplying by 4. So the minus 2 is first, and then we're multiplying by 4. Okay, so how does the minus 2 move it?
Right 2.
Yep, right 2. Okay, and what's the 4 do?
Vertical stretch.
Vertical stretch by 4. See, I think that is easier than what we just did above. I think tearing it apart is easier than putting it together. Okay? Good, good? Alright, now we're doing symmetry. Symmetry. Okay, there's 3 types of symmetry, and they are x-axis, y-axis, origin. Let's put it off to the side over here. X-axis, y-axis, origin. Okay, do you remember how you check for this? Whether it's
Okay.
x-axis, y-axis, or origin?
Origin you plug in 0 for
Yep, so x-axis I plug a negative in for the y, right? So x stays the same and y becomes negative, okay? If it's symmetrical with respect to the y-axis, I plug a negative in for x, right? So negative xy. And if it's origin symmetry, yep, both of them are negative, okay? Now what are you looking for when you plug the negatives and stuff in?
Make sure it stays the same.
Yep. Back to original, question mark?
Which one's, y-axis is even, right?
Yep, I'm gonna write that down. So, y-axis is an even function. Origin is an odd function. X-axis is neither. Why is x-axis neither?
Because we want it to be, it flips over.
It flips over the x-axis, so it'd be like a parabola on its side, but why is that not even or odd of a function? It's not a function to begin with, right? It doesn't pass the vertical line test. So, that's why it's a neither function, okay? What happens if it has none of the x, y, or origin? Then what is it? It's neither also, right? Okay, so there you go. All right, so let's do that here. We're checking x-axis, y-axis, origin. Some of you guys can do this without even like plugging stuff in. Anybody in that boat? You can do this without actually plugging stuff in. So like I look at this thing and I'm like, okay, let's check the x's, right? If I did the x's, right, this guy would switch back to a normal, right? Why? Because it's x squared. Would this guy switch back to normal? No, so x-axis, like if I plug a negative in for x, is not going to switch back to normal. You see how that works? Negative x is not gonna work.
So it's not
Okay.
symmetry.
So, negative x equals no. Okay, what if I plugged a negative in for y?
Yes.
Is the negative in for y gonna switch back to normal?
Yep.
Yes, because I'm gonna square it. So negative in for y equals yes, right? Okay, what happens if I do a negative in for x and a negative in for y? Because the x is not gonna work, so that's gonna be a no, right? So this was a yes, which means it has what type of symmetry? X-axis, right? If the negative in for y worked, then it has x-axis symmetry, okay? Do you guys want me to write that out completely and show like all the steps? Do you see how that works? Anything that's squared or to the 4th power, anything like that, is gonna switch back to the normal sign, right? So you guys can see kind of how that works, okay? Without actually doing all the work and stuff, okay? Just make sure that you're careful and not making a mistake. Got it? Okay. That was 30. Should we do the next 3 and finish chapter 3? Yeah? Okay, let's do it. So F composed of G, which one goes inside when we do that? G goes into F, okay? So G, thank God. Are you guys looking at this? What if we put F into G?
Yeah,
Then we would have to FOIL and do all that stuff. So yay, we did the nice one, right? We're putting G into F. All right, 6 plus X, and we're putting that chunk into the X, right? The other way around would not have been so nice. Plus 1. Okay. All right. Now what?
You add 6.
Yeah, I add 6. This parentheses aren't really doing anything. Okay. So I just combine the 6 and the 1. So x squared minus x plus 7. Yeah, there we go. Yay. Okay. Questions about that? Thank goodness I didn't make you do G composed of F. That would be icky. Okay. 32. Find the inverse. Okay, inverse. There are 4 steps to finding the inverse. 1, 2, 3, 4. You usually do 1 and 2 at the same time. Number 1 is switching f of x and calling it y. Number 2 is taking x and y and switching places with each other. So I do a double-sided arrow. You guys see my notation over there? Does that make sense, that notation? Okay. All right, what's step 3? The longest step. Solve for y. You get y by itself. Solve y. Okay, and then Step 4, after you solve for y and got y by itself, he switches back to his original name, but he's the inverse. Okay? So if it was f inverse, or f, you call it f inverse. If it's g, you call it g inverse, etc. Right? And inverse looks like the minus 1 power. Confusion by any of this? Doing okay?
Hold up.
I'm holding up.
Okay, you're good.
Okay.
Thank you.
Find the inverse. Find the inverse. Okay. Step number 1 and step number 2, you want to do them at the same time?
Yep.
So this guy becomes x, right? And this guy becomes y. xy, got it? Alright, we're solving for y. I'm trying to get this y by itself. Alright, so we've got to move everything on the right side over to the left side. It's going to be like 3 things that we have to move. We have to move the 3, we have to move the 7, and we have to move the 4th power. Okay, not necessarily in that order. Which one goes first out of those 3 things?
Divide by
3.
3.
Divide by 3. Okay, let's get him over to the other side. So now my first step looks like x over 3 equals y plus 7 to the 4th. Got it? I've divided the 3 over. Now what do you do?
Take the
4th root.
Take the 4th root. Oh, we're going to forget something. Maybe not. We're going to take the 4th root. So we have y plus 7 is going to fall out of there. On the right side, or on the left side, the 4th root of
X over 3.
x over 3 is not quite right.
1/3 x.
Plus and minus.
We need plus and minus. Do we need a plus and minus if we do the cubic root? Or the 5th root? Or the 101st root? Heaven forbid we actually have to do that, right? If it is an odd powered root, we don't have to do plus and minus. If it's an even root, we have to do plus and minus. Okay? Alright, now what? Minus a 7. Where do I put the minus 7 at?
at the back.
You want to do it in the front or the back?
Front.
Like we're kind of used to doing the quadratic formula where the plus and minus goes last, right? Does that look okay? And then step 4, we're gonna switch it back. What was he called to begin with? F inverse. I'm gonna put that first. That was kinda ugly. Did you follow those steps though? You're like undoing everything. Like we don't have to solve it from there, so that makes it kind of nice. Or we don't have to find the domain. That would be maybe really super ugly. But did you follow those steps? You're unwinding it. You're trying to like undo the order of operations, right? Okay. Those 2 are inverses of each other. Yuck. Good, good. Okay, one left. Average rate of change. What does average rate of change mean?
You just plug in this. within
Slope. Average rate of change is slope. Okay, how do you find slope?
y1 minus y2.
Yeah, y2 minus y1 or y1 minus y. It doesn't really matter what order you subtract them in. They just always say y2 minus y1, x2 minus x1. Okay, that's how I find slope. Okay, now look at what I'm given. They give me the function, and they're saying when my x's start at 0 and my x's go to 2. So I have x's, but I have no y's.
Look at it.
Yeah, I can plug those in to find the y's, right? F of x, they give me the output, like the rule for the y's, right? So if I plug 0 in, this would be 0 comma something. If I plug 0 in, I get 2?
Yeah.
Yeah, if I plug 0 in, okay. If I plug 2 in, 2 minus 2 squared, negative 2, yeah? Do I need to write any more work down than that? Like, does that, did you see what I just did?
Yep.
Okay, if you need to put, like, plug in to find what? The y's, you can. They're just as a little reminder, like, when you look at this and you're like, where did that come from? Now we just do slope, right? What's your second y coordinate gonna be?
Negative
Negative 2, sure. Minus 2 over 2 minus 0. Okay, that is negative 4 over 2, which is negative 2. So it is changing at a rate of negative 2 whatever per whatever. So like feet per second or inches per minute or whatever the units would be on this function, which it doesn't have, but that's the rate of change. It's changing at a rate of -2. Good? Makes sense? Rate of change is just slope. Got it? Alright, should we stop there?
Yes.
And then we stop right before division. Great. Woo!
You should just, give us a test now.
Yep. Okay, I'm going to stop the video. There you go.